Cybersecurity concerns are ever evolving. OT cybersecurity is even more complex, and it's so much more than just software and hardware. How do you stay on top of it all? Aaron Crow has over 25 years experience with cybersecurity, 15 of those years focused on operational technology across multiple industries, and he wants to help you. Welcome to the Protect OT Cybersecurity Podcast, brought to you by Industrial Defender. Now here's your host, Aaron Crow.
Awesome. Well, thank you for joining me today, Pete. Why don't you introduce us, tell us who you are and a little bit about yourself and your background.
Sure. My name is Pete Mauro. I have a BS from Drexel University from 1993. Worked for the military since I was in college as an intern, primarily for the Navy. Started in July of '89. So I got 34 plus years in the DoD and Navy industry, primarily as an electrical engineer and systems engineer. Large background in controls, which led to automation, which obviously leads to cybersecurity and protecting the systems that we architect and field, especially in our military. And that's kind of where I landed as a contractor. I spent my first 12 years as a civil servant GS in Philadelphia and Washington, D.C., working for NAVC. But the last several years, couple decades actually, have been as a contractor, business owner, entrepreneur. And recently I sold my company, and this is where I am today, having fun and trying to protect military and non-military systems out there in the wild.
So how was the transition from, doing systems from before cyber to how that, like you said, it naturally kind of progressed into cybersecurity being something people are talking about and caring about? It was always kind of there, but we didn't call it cyber. We cared about, availability, but it's the same processes. We just put different labels and had different attack vectors, right?
Yes, it's a great question because there's two answers I have personally. One is the word cyber I didn't know about back in the early 2000s, but I was a security engineer in a sense. When you design a system, you can't just design it for functionality. You got to design it for safety and security. As more and more operational technology devices became smart and had computers on them, we had to think more about the cyber word and the cyber aspect of that security. And that is the natural inherently tendency for me to get into that, but I had a huge T&E background, test and evaluation background, and what that means is I had to look, and that was all kinetic, that we had to look at the susceptibility of ships to different threats around the world, very secret, top secret type information. That information got fed into what we call a vulnerability model, which some of the Navy built a vulnerability model for kinetic weapons. You would take the susceptibility output, put it into the vulnerability model. It would tell you what broke on the ship. And then from there, we had a recoverability model that I was a huge part of developing. Again, all kinetic. Right. And that would tell you how the ship could recover from the baseline of damage that it took. Well, all cyber is a different threat vector. It's just colorless, odorless threats that are harder to predict. But the theory and the process and everything else is the same. So I had a really big head start in the cyber realm because of all of my kinetic susceptibility, vulnerability, and recoverability experience.
Yeah, it's the same skill set, building a team at a power utility, and at the time there were no such thing as OT people. That term was fairly new in the marketplace. And I was hiring, but there was nobody with the skill set. So like my manager wrote like a business, the job rec. And I kept telling him like that, yes, those are the people that we're looking for. The problem is those people don't exist. So these are the things that I need to focus on. So I was able to go hire people that had networking skill sets and troubleshooting backgrounds and things like that. And I was able to teach them the OT. I was able to take them to power plants and take them to substations and teach them that side that they, most of these people came from IT. They came from working in law firms and working in data centers, and they had no understanding of the OT side of that, but it was the same skill. It was, if they could troubleshoot and they could do the networking, they could do it in a power plant or on a ship or in a base or in a manufacturing facility. It didn't matter, as long as they understood the business use was different. Like on a ship, to your point, like I care that ship can get me home and that can keep the sailors on that ship safe and can do their job. If they need to deliver something, or whether it's a payload or it's people, they need to be able to do that and have their mission be successful and get them home. Right? We care about that.
So two things, Aaron, that really, one funny and one serious, that got me from just doing secure engineering, understanding that it was cybersecurity now. But one, I shouldn't say funny. One had nothing to do with me, but IT folks tried to run a scan on an OT system on a ship. And it happened to be while an admiral was touring the ship. It was a DDG, a destroyer, a new destroyer, an Arleigh Burke class. And they ran a scanning tool, I don't know what it was, on the AFFF system. And if anybody doesn't know what that means, it's aqueous film forming foam. It's not fun to clean up, and it's used to die out fires. And the scanning tool lit off an AFFF valve, and it almost hit the admiral while he was walking on the flight deck. That was one of the things that really got me and the team that I worked with at Naval Surface Warfare Center in Philadelphia really into figuring out how to stop people from doing that and use the right tools and understand there is a very big difference between operational technology and those networks and the information and technology networks that people are used to dealing with at their office. Yeah. The other thing was, I was asked as a subject matter expert, let's flash forward all the way to about, the late 2000s, 2008, 9, I was asked by my customer to start helping write an architecture spec for all the Navy to use on how to control machinery control systems, which is the octopus of a ship in the non-combat world, the HM&E, hull mechanical electrical world. So in that mill standard, I wrote, there was a section on security, and we called it cyber warfare back then.
Right.
And we did the best we could. And basically what we said was, look at all these things, do an assessment, design your system, and then assess that system. The problem was we didn't have any good tools that would quantitatively assess a complex warship like a Navy ship, right? Yep. And you're talking about a ship now with all the computers everywhere, designed down to the field device level. You're talking about anywhere between 150 and 300 systems that are all interconnected and all depend on each other to fulfill 5 or 6 missions of a ship.
Right.
And we needed to understand how those things affected the mission of the ship. Right. And RMF was the best thing we had. It wasn't even called RMF back then, but today it's a risk management framework. But if you look at any RMF package, there's almost none that don't get the checkbox. Right. And it's a bunch of paperwork. And listen, I'm not saying it's bad. It's what we have. Right. But we decided in the early 2010-ish arena that we needed to come up with something. And by 2014, when this document was published, we were like, all right, great. It says to do this. Now we have to figure out how to do it. And I got with my team, which was my company at the time, as well as my Navy team, directed by the Navy. And I purposely developed a tool that was owned by the Navy. It was a vulnerability assessment tool specifically designed for assessing cyber vulnerabilities in complex weapon systems. There's a patent on it. It's a shared patent between my old company, which is now owned by someone after I sold, and the Navy. And it is in use, and it is plugged in as part of the Navy's RMF process to do some of the quantitative analysis. And I don't want to go too deep into that, but that kind of were the two things. One was, just something bad that happened, and two, a problem we had that we had to solve that led me really to get deep into cybersecurity and really focusing more on it now than even the design of control systems.
Yeah, and unfortunately, I've experienced that mindset so many times, even IT world, whatever. Working at a large Fortune 500 company, and working on an IT system that wasn't critical. In the severity of applications, it was ranked pretty low until something happened, and it was an email server, and email wasn't critical until the email server crashed that had all of the C-suite executives' emails boxes on it, and they couldn't get their email, and they were going through litigation that was requesting the emails from a certain time period. That became really critical really quick. So why is it, especially in OT, as we know, these are critical systems, like everything that we do on these systems are critical, but cyber seems to be dragging as far as doing the right things from a cyber perspective. To your point in the beginning, it's just another risk. It's no different than safety or anything else on these ships. Cyber is just another risk. It's not a different thing, but it seems to be we've been dragging our feet to actually mitigate and do the right things for them.
So I don't want to make this sound like everybody feels like this, but I'm going to use the statement, ignorance is bliss. Okay?
Right.
And I don't mean that people, high-ranking or low-ranking officials, whether it be critical infrastructure, the Navy, the Army, I don't mean that they're ignorant. But
Sure.
what I do mean is they don't fully understand sometimes the actual risk there is, because no one's telling them. And they have the best we have, RMF, paperwork that gives you a check in the box that says, listen, we can't protect everything, but we're doing the best we can.
Right.
But in my humble opinion, using tools like Industrial Defender, the tool that we built for the Navy, and several other tools, I'm not saying
Sure.
there's one tool out there, we can do better. It's a culture change.
Right.
And what I concentrated on, Aaron, to get this done, at least in the pockets that I lived in, or that I live in still, was saving money. Because even though the example you used will have its peaks and valleys, when someone has an issue, they will spend more money on cyber.
Right.
But then it kind of falls off and it becomes, hey, we're still okay.
Right.
Where if you can figure out how to make security better while saving money, then you have something. So what I did was, I like to listen to my leaders, right? And my leaders in this world are the DoD and the Department of Navy. And they put out in 2019 and 2020-ish, a digital engineering strategy document. The DoD did it and the DON derived it. And it is a better way, and it's basically what we did in the early 2010s on how we develop this tool. We just did it before it was a strategy. And what I did was I showed my customers and the higher ranking officials that were in charge of things is, if you use cyber as the jumper cables to get the car started, and you model and you use model-based systems engineering instead of just the good old system engineering tools like CAD and Visio, you've gotten the start of a model-based tool that you now can use for RMA. You can use it for obsolescence management. You can use it for configuration management and change management. And I showed my customers how you can model the ship, use that model to ingest into this cyber tool that we built, but don't throw those models away. Look back at your strategy, see that it says, now that you've used models to do digital engineering, use it for everything. And we showed, for instance, a cyber tabletop, where you lay out everything on a page, on a big conference table, computer, whatever you want. You get subject matter experts in the room, and you say, if somebody would attack from this vector, whether it be cyber or kinetic, in this case, we're talking cyber, we showed that by using our tool, where you have a model of the whole ship and all the interconnections of the systems internally and externally, you can do that a lot quicker. And we showed a savings of 30 to 50% just in the cyber tabletops.
Right.
So now we're showing you can be more secure and save money, not only in cyber, but in other areas. If you then take that model and you start using it for your configuration management and change management for that ship class.
Right.
And that's how we kind of sprung board doing more with what cyber was, having a hard time with.
Yeah, and dude, that is a great model. Like, again, going back to my experience, which is very similar, right? Is doing it in power utility. One of the first large programs that we rolled out, probably like 2010 timeframe. We didn't have budget. Like we didn't have a big cyber budget. And I was going to these customers, which were, part of my own company, but they were the plant managers, right? They were the site owners, and they had a budget, and all the work that I was going to do was going to take money away from something else. I wasn't going to do boiler maintenance, or I wasn't going to, deploy this new capability that was going to make the site more efficient, or was going to lower risk, or whatever. In the beginning, we were hitting walls because all we were is a cost center. We were adding costs that they saw no value in.
Right.
So I had to change my story and show how can I bring them value and not talk about cyber. It's not that they don't care about it, but it's not in their, especially back then, it wasn't in their front sight focus. So they weren't able to see the value in it. So I was able to show them operational value. How could I save them time? How could I save them money? How could I save them misconfigurations of their endpoints? And when I did that, it changed the script, and they were more open to me being there. And even though it was a cost, they were getting value that they could justify. Because at the end of the day, it's all about the value and running that system of whatever system it is, and maintaining it and being profitable or valuable in the use case.
100%. And that's the key to getting more done anyway, right? We have to always continually get done more with less, more with less. And if we try to do, and I've told my customers, if you take what we did here and you keep doing it over and over again and keeping it hidden from the rest of all the work you do on a ship, it will fail. You don't have enough money to do it. You must incorporate it. And I would point up to their document, like you told us to do in this strategy document. And that is how listen, to be honest with you, I owned a $4 million company. It was not much to brag about, right? It was a very flat company. I had no managers. I managed all the work. I worked as an engineer. And I really sold because I liked being an engineer more. And we had developed this patent with the Navy, which got the attention of one of my primes. Well, we got bought by private equity. We all know private equity doesn't buy you to keep you. But for the next 3 years, I worked my tail off doing good work. But that good work led to a larger $3 billion company buying us. And if you listen to why they bought us, it was Mantech. It was all about digital engineering and cyber. And it was not Navy. It was an entire team. I was just part of that team. But it was following that path that I just went over, which got us to be unique and not just another service provider growing organically, in the DoD and defense sector. So it does work. It's repeatable, and I'm trying to repeat that now in critical infrastructure with some of my newer clients. While I still am trying to support some of my older clients as well, because the work will never end. It changes so fast.
Yeah, and too many of the vendors that I've seen in cyber specifically, that it's all fear. Hey, bad guys are coming to get you. You got to buy my tool, or the sky's falling, Chicken Little, right? And then to your point, maybe they get people to buy, but eventually they're like, wait, nothing ever happened, and your product didn't add me value. It's actually really expensive. It's hard to use. What I don't need this. Because it's not providing any operational value, or they're not focused. Maybe it does, but they're not using it in that way because you sold them on the fear instead of what can I use this for? How can I integrate this into my process and become part of the overall solution, not just a doomsday scenario that may or may not ever come.
Right. And one of the things that you made me think of a little earlier was when you're talking about finding people, they don't grow on trees, and they don't. And everybody that could do what I needed them to do wanted top dollar. And if anyone listening knows anything about the federal government industry, it's a lot about low price. So we couldn't pay everybody top dollar. So what we did was we took our smartest folks, we created a training program, and we took in, look, this is literal, failed nursing students that had an IT background, computer science majors that were looking for a job, any type of engineer that was interested in security. It was much easier to take those folks and train them than it was to take a high paid, expert and make them do the low level work we needed them to do. And we built out a training program internally that produced about 100 digital and cyber engineers and technicians over about a 2-year period.
And that's huge right now. You see it in the news all the time, talking about the shortage of cyber workforce, right? I can't remember the numbers, but they're very large, and it's even more so, and that's overall IT side of cyber. When you start focusing on OT and even more specifically critical infrastructure, there's not many people that have the hard hats and have been to power plants or been on a ship and really understand why, the example you gave earlier, why I can't just scan an OT network when an admiral's on deck, and how that could be a problem.
And it's not about smart or not smart, right?
No.
We've talked to very smart IT folks, and they just don't understand why we can't do certain things on a ship. And it's not, you can't explain it to them. It's years of experience that took us to where we are. So that's what led me, and developing that training program was certainly a profit-driven idea.
Sure.
But now in my second part of my career, as you know, a new business owner, but not one that's looking to grow a company, I'm doing a lot of volunteering and some work at Rowan University with some of my colleagues that I worked with before, developing a cybersecurity certificate program that focuses on OT and IIoT, right? Industrial Internet of Things, because that's where I see the need. That's where I see we need to produce more good engineers that come out with not just an IT background. I used to tell engineers when I was young, go get a minor in IT. It's very important for you to understand networks. It has become so prolific now. Now I tell them, get a minor in cybersecurity, because that's what you're doing, and concentrate on the engineering part. And listen, I had to physically describe why my cybersecurity certificate program with Rowan was different than the computer sciences cybersecurity certificate program, because they're very different. One concentrates on, you know, policy and IT centric stuff, where we're down in the hardware, the firmware, the engineering side, and there's a big difference.
Huge difference. And to your point, like, you know, same thing. So hiring people, bringing them in, but it seemed to be harder bringing the IT people with, you know, high skilled folks that were very good, but teaching them and making them understand why I couldn't do the same things that I did in IT. I can't just take that IT policy and push it down. I can't just reboot a machine. I can't just push a patch. I can't just do those things. And it was harder to get them to understand the why until they were at a power plant and the unit tripped and they saw what happened when something like that went down.
Or in my world, when the person writing the requirements to put HBSS on a Navy ship, and you're trying to scan a system that's not on the gig or the DODIM, it's useless. It's not helping you. It's, in fact, it's corrupting the actual system that you're trying to, you know, field on a ship. So not until, and listen, once the requirements are written, the shipbuilder bid and design the ship, it's an uphill battle for the next 50 years that ship's alive. I mean, it's not easy to make change.
Yeah. Well, and it's that way in everything. And OT, you know, these OT systems, and that's a great point to bring up, right? Is their life cycle. IT's life cycle is what, 3 years now? Like, you're replacing hardware constantly. Same with software. You're coming up with the newest version. Windows, you know, Microsoft patches every patch Tuesday. I mean, it's a very short cycle of change, and laptops are adding applications, and you're going to the internet, and you're taking your laptop to Starbucks. Like, these are not the use cases that we have in OT. Like, the life cycle on a ship, the control system is going to run it until it dies in 50 years. It's a different model.
And I'm sure you've lived this just as much as I have. The old adage, well, it's not connected to the internet, so we're good.
Right.
And I have a simple thing, whether it's a 101 class that I'm doing, or it's, you know, even engineers that just, you know, are lazy, right? It's, well, how did you update the firmware or the software? Well, I use my laptop. Well, where's your laptop? Well, it's in the lab. Well, how did you get the right drivers? Well, wow. So, and listen, there's ways around that, right? There's scans, and you can't touch things, but you know, here's the quantity on just one ship, right? There's about 6,500 field devices on a ship.
Right.
What about the OEMs, right? That come on the ship, especially when there's an emergency and they have to update something because something's not working. Yes, we do have policy and we do have processes, but if every policy and process was followed to a T, we probably would be about 3 years behind on everything, if not more. So we know they're not all followed. So we need to have that's that zero trust mentality. We have to have multiple ways to protect our systems, our components, all the way down to the field devices, which is very different than, you know, an IT system in a bank or a power plant, for that matter.
Well, and it's just like anything else. It's security in depth. Like, I don't just have a lock on my front door. I also, you know, have cameras and monitors and sensors and other, you know, in a 357 and, you know, everything else, right? I don't just trust my front door, because I know that's really only keeping my neighbors out. If a bad actor wants in my house, that front door is not going to stop them. They can drive a car through it. They can hit it with a sledgehammer. They can pick the lock. They can break the window. There's 100 ways they can get in this house. I need to have multiple ways. And the same thing in cybersecurity. I can't just put a firewall out and expect that's good. I can't just disconnect my system. Well, it's air gapped. Okay. But it's never actually air gapped. There's always that way in. There's always the secure mode access or the vendor's access or somebody sneaker netting it or connecting their laptop that's been at Starbucks. And I have a story from a nuclear power plant that the crane that actually controlled the nuclear rods, the vendor brought in his laptop, plugged it into that to update the firmware on the actual PLC that runs the device and got malware on it. 2 outages in a row because they had no idea how it happened. And his system was scanned. It's not like he did anything wrong. He did exactly what he was supposed to, but 2 times in a row, 2 outages in a row at a nuclear facility inside the protected area, it got malware on it.
Listen, some things I can't talk about in specific, but the specifics don't matter. On a very important warship, in a very important system, was the printer, just the printer.
Right.
Well, you can't print to a printer if the printer's not on the network.
Sure.
And there was an exploit in the printer that was exploited. It was a vulnerability in the printer that was exploited, and it took down a serious system just from a printer vulnerability that in an RMF package may not look important.
Sure.
And there's hundreds of millions of vulnerabilities out there, especially when you're talking about 150 to 300 systems. And you also made me think more 101 type classes that I'll teach or talk about in a seminar. I tell people putting on locks on your doors and your garage doors, your front door, your back door, and not paying attention to your windows is like only securing your IT system and leaving your OT system alone because it's not connected. And it makes it more understandable to the layman who doesn't really understand other than the word cyber. And it's a good way sometimes to analogize the physical security aspects that are very similar to the cybersecurity. Details different, but it's good to assimilate those two. It makes people that don't understand cyber as much at the detailed level understand why they at least need to protect what they need to protect and what they need to do.
And that's one of the things I love and am so passionate about, having conversations like this and doing podcasts and getting that message out, because we've got to have different conversations, and we've got to have that conversation at all levels, from the top level, the admirals and the executives, all the way down to the boots on the ground that are turning wrenches and configuring firewalls. Right? Is it needs to be done, and these conversations need to be had earlier and earlier. And you mentioned, it needs to be done when they're designing the ship, not just, bolting it on after the fact. And obviously we can't go back in time. What's done is done. That doesn't mean we can't do anything about those. But when you start making sure that this is a risk vector that is included from the very beginning in all of these conversations up and down the chain.
But there are tools out there, as you know, that are for, the older systems, the, greenfield, right? New stuff, easier if you put the time in up front, right? The brownfields are harder, but there are things out there. I'm working with several companies. Look, I had a year that I basically took off after I resigned after the second sale of my company. And it was nice because I was able to go out there and research. And I picked a handful of companies that I really liked, that all kind of, when you put them together, they build a nice little almost zero trust architecture. They're parts of a zero trust architecture, and they're both for green and brownfield systems. And you can do it. You need to do it different. Yeah.
And it goes back to looking at it from the perspective of, it's just another risk. Cyber, it can be overwhelming. It can be scary because we're talking about nation states and China and all of this really, scary stuff. But at the end of the day, it's just another risk. It's no different than any other. It's just making sure you're going through that risk profile and understanding what my risks are. How do I recover from it? I can't patch everything. I'm not going to be able to go retrofit every ship that I have in my environment.
No.
That doesn't mean, to your point, that doesn't mean I can't do anything. It just means that maybe I approach that and I mitigate it differently.
And understanding. And this is why I was interested in talking to Industrial Defender, because before you can protect anything, and this is part of what we did with the Navy patent, is you need to understand your system. And when your system is complex, it's not as easy to understand it. It's, trying to protect a system you don't understand is kind of like playing darts with a blindfold on. I mean, you might hit some of the high things. Oh, we need to upgrade Windows 7 to Windows whatever, right?
Right.
But you don't really know that might be the most important thing. It might be something else. And I'll tell you what, I don't know about, I'm not as in tune with critical infrastructure, but I know in any industrial control system, like a Navy ship, it takes literally a couple of years and millions of dollars to upgrade from Windows X to Windows Y, whatever the upgrade is. If that's not doable, then you need to come up with a low-cost solution. And that might be segmenting parts of the network, the most critical parts, with things that with technology like, millisecond encryption that can protect things that you wouldn't think you would do functionally, right? Because here, security and functionality will never stop banging heads, right? That's
right. Yeah,
that is a fact, right? And I tell people, yeah, you don't like putting your password and multi-factor and your fingerprints and this and, but you know what? The alternative is a lot worse. So it's the same thing. You have to be able to add things that sometimes aren't needed functionally to be more functional.
Well, to your point though, right? It's that functionality has to remain, and that's one of the prime drivers and differences in OT and IT, right? Is I can be more painful on the IT side and people deal with it, but on the OT side, I can't lock an operator out of a screen when they need to be able to control the thing. Like I can't make it, a Navy ship. He has to be able to drive that ship. He has to be able to fire that missile. He has to be able to do those things. And I can't put a security control that's going to stop it. Like I have to fail open. I have to make sure that no matter what, they can do its primary function, which is different than IT.
100%. It's like, cat cards, right? Or you can't, if you forget your card and you need to launch the missile or shut the valve, you can't not be able to do it. There has to be an override.
Yes.
But that's in conflict with some of our cybersecurity rules and policy. And that's why it's gotten a lot better. We have a lot more OT expertise into that policy, at least in my world. So it's gotten better, but it needs to improve, and the tool sets need to be more widely adopted and more culturally accepted. The technology's there. I do not believe it's a technology issue. It's a cultural issue.
No, I agree. And I think that you mentioned earlier about the ecosystem, of it's not one tool. It's this tool fixes these problems. This tool fixes these problems. Right. And we've done this in IT for years. It's always been an ecosystem of tools, because not one tool is going to do it all. Right. And if you try to get one tool to do it all, it's probably not, it's going to be, a master of nothing. It's going to be decent at everything and not great at anything.
That's right. That's right. It's definitely a mix, and it's definitely a trade-off. Right. You have to mitigate risk. You can get rid of some risk. You can push some risk to insurance. I got really interested in how the insurance industry was handling this from you're insuring somebody. How do you really understand from a couple of check boxes on a survey that you gave them? And I realized, doing a lot of research for about 3 to 6 months, that they still do not have a good way of understanding how secure these companies are on their OT side. They have great ways to understand the IT security, but they do not have good ways to understand the OT security. And that's coming from, a lot of major companies that formally told me that we would use a tool for OT assessment to rate our clients. So
and unfortunately, again, this is 2023. This is, I've been doing this a long time, and most large clients that I walk into, I would dare say, I hate to say all, but dang near all, don't have an understanding of their OT environment. Like, they have a conceptual idea, they have a basic understanding, but they have, asset spreadsheets, it's in a spreadsheet, or it's in Tom's head, and, Bob left the company, so we don't know how to get into that system. And it's not anywhere near where it needs to be to really, to your point, how do I protect something I don't know where it is? I don't know what my vulnerabilities are. I don't know where my important assets are. Like you're in the blind. You're hoping, you're plugging the right holes in the dam, but you don't even know where they are. So you're just really blindly looking around trying to find them and hope you found the right one.
And that creates a very reactive environment versus a proactive environment. So there's a lot of work to do, and that's why we're talking about it. And
that's right.
I think that it's not, once software became so prevalent way back when, things can't just be left alone, right? I worked with some customers that didn't upgrade like the Navy upgraded, without mentioning names, and they used to just leave it, and if it ain't broke, don't fix it. And I tried to explain to them, as we're putting more and more software on chips, we got to look at upgrades that have to happen even when something's not broke, or something will break and you won't realize it. Well, take cyber. I mean, that is like on steroids, the change. I mean, you have to be looking almost weekly and daily versus semi-annually or annually at software versions and things like vulnerabilities and 0 days. And then you have, what's the new term? It's not that new, but your everyday threat, or obsolescence is a big issue out there. And these big companies, I work with Rockwell, I work with Siemens, they can't keep up with all their products all the time.
Right.
And some, plants can't afford to upgrade all the time. So you have to figure out how to segment old equipment that cannot be mitigated from a cyber perspective. So you just have to protect it a different way.
Correct. Yeah. I mean, in our product, we just recently, like the last version, stopped supporting NT 351 and NT 40 because we had so many clients up until now. Again, this is 2023. When I first got into IT, I was supporting NT 351 like that. It's been a long time, but there's still industrial clients that use it. And we just now stopped support of it. But that's what it looks like in OT. It's, again, we keep going back to the difference between IT and OT. It's just different. But it's Sun Tzu art of war. You use your strengths as weaknesses and your weaknesses as strengths. So even though I can't update my systems all the time, they don't change as often. So I know once I am able to understand what my environment looks like, then I know it's not going to change. So those changes, if there is a change, that's more than likely going to be something I can look for. I can know what good is, then I can start seeking out what bad looks like.
Right. And one of my clients that helps, they do both, but they help a lot on the brownfield stuff, the stuff that you just can't fix. And they have some technology that really helps segment, even in a place where you need to parallel a generator and you can't have any latency, you need very, very little latency. And they analogized it to exploring in the ocean, right? IT is kind of like snorkeling and maybe getting the tank on and going down, 25 feet. Well, that's great for IT, but when you have to go down to the depths of the ocean, it's dark, you have to bring your own light, you don't understand what's there. That's kind of the OT area, right down at the PLC level and below. And that is harder to protect because it's harder to see and harder to understand. And like I said, we gotta first understand it, see it, lay it out, and then we can protect it. And sometimes the answers are simple as long as you understand what's there.
So have you had success having those conversations and turning people and making them from an asset owner, or from all the executive level all the way down, understanding how they can be successful and march forward? Because I know a lot of folks we talk to are just like, I don't know where to begin. I don't know what to do. Like, how to help me?
So I'd say that I've had pockets of success, and it's not the right way, but it's my way. I believe I need a top-down approach and a bottom-up approach. So
sure.
For instance, in my world, right, which is easier to talk about, I will talk to the low-level engineers at a shipbuilder. I will introduce them to a tech that I believe, because I understand the systems they're working on.
Sure.
And I'll say, why don't you try this out? I'll get one of my clients or anybody, to give them a demo version for free so they can play around with it, understand it. At the same time, I will go to the tech warrant holder in the Navy and say, listen, I'm not asking you to do anything, but I believe there's an easier way to do what we've been doing. It'll make us more secure and potentially save us money, and we can reuse it for some other things, depending on the situation.
Sure.
And I will work with both until they meet in the middle. So when the lower level engineer brings it up to his chain of command and says, hey, I think we have something that can meet this requirement, it'd be cheaper and simpler. Simple's big. We have 18 and 19-year-old kids on these ships operating these things. You can't make it complex. When that gets up to the point where the shipbuilder wants to suggest a change, now the tech warrant has already at least been aware of what the technology might do and has a more open mind to listen. Now, does that mean that everything I propose works out? No. But that is the recipe I've used that has had pockets of success.
Yeah, you know, one of my mentors told me that all business is a people business. He said, I don't care if you're the CEO or the janitor. We're all salesmen, and we all have to be able to connect and basically tell, you know, explain our story, because it's all a story. Like, what is the message you're trying to get? It's not about the tech. It's not the ones and zeros. It's not my product. It's about what am I trying to solve? How am I trying to help you? And how is what I'm telling you going to help you versus just get me a $sign or, you know, sell me some software.
You know, I'm so glad you brought that up, and I'm so glad you used the words CEO and janitor. And I'm going to just for 30 seconds detract from our conversation technically and tell you that, you know, I sold a couple of companies. I've been involved on advisory boards, and I've gotten accolades. And I'm not that great, but I've had a lot of things in my life that have been, you know, things I could be proud of. But I would tell you one of the most proudest things that I've had is a compliment that my little brother, who's 48, gave me probably 10, 15 years ago. And what he said was, you know, you speak the same way, whether you're talking to a CEO or a janitor. And that is something that's inherent to me. I don't know. My parents taught me to respect everybody.
Sure.
But I guess that's why it works sometimes, because if you treat people the right way and you take the time and put the effort into explain things, and explaining something to a CEO versus a systems engineer versus a software or hardware engineer, you might say the same thing, but you better couch it different. That CEO has maybe 60 seconds to 5 minutes to hear you, whereas the engineer might want to talk to you for 3 hours.
Right.
So you need to be able to speak and articulate the same thing very, very differently. And that sometimes is the difference between success and failure, not what you're doing, but how you articulate.
100%. Right. And you've got to be able to have that ability. And that's where the uniqueness, you know, in my career, I think that's one of the things that's made me more successful is I can have those deep level conversations with that engineer, but I can also talk to the CEO and explain to them in a way, in a short manner, in a way they're going to understand without them thinking I'm talking over their head or talking down to them. Same thing on the technical side with the deeper guys, you know, not thinking I'm some guy wearing the wrong shoes and a fake suit, and it has to come off genuine too. And that's not something you can fake. You know, again, those hard hats are not fake. Yeah. They're not prop. Like I wore those, and that's the reason they're there. It's because it was a part of my career, and I still wear them. Like I still go to sites and that. But again, it comes off as natural. That's why I can walk into a power plant or, you know, a ship or a manufacturing facility, because I've been in their shoes. And I've worked those roles, so I know why they're hesitant. I know what problems they're having, so they're more open to hearing me talk versus somebody that hasn't experienced what they have.
Right, and you know, it's another reason why I never, as a small business owner who did, you know, took the trash out as well as, you know, pitched, you know, the biggest proposal of my life. I never had a title on my card. Because when I went and talked to a bank when I was trying to raise money, I didn't want them to see electrical engineer. But when I went and talked to the engineer on a ship and I was trying to fix a problem, I didn't want president on there and them to think that I didn't know anything.
Right. Exactly. So, it's all about that perception.
Yes, absolutely.
Well, hey, so man, we've talked about a lot of things, from good things to scary things. In the next 5 to 10 years, what's something that you're excited about, like happy for, or looking forward towards in cyber, and maybe something that's concerning that you kind of see over the horizon that we need to pivot on?
Sure. So as a true engineer, I'll start with what I want to do with the rest of my life. As a true engineer, on my new website, I'm a one-man show now. I started a new company, and it's a Venn diagram, and it's got 3 bubbles: what I'm good at, doing good for others, and being appreciated. And in the middle, of course, of the Venn diagram, I try to only work on things that meet all three of those criteria. And Rowan University has become sort of a center of my world because I have a charity that does a lot with Rowan as well. So that's part of it. But it's all about the young engineers. I sit on the advisory board for the engineering school. In fact, right after this, I'm having lunch with the dean of engineering, trying to plan out next year.
Yep.
It's the center of, bringing young engineers into the world of OT and engineering where I live. It's dealing with Lockheeds and the small business owners that I also work with, helping Rowan. We're trying to build a huge 200,000 square foot building that will be very secure, if you will, where we can do a lot of the cyber work and high volume security type work, top secret and above. And I want to be able to create a pipeline where you have universities, industry, and government. And that recipe has worked very well around the country for technology. And I want to do it for cybersecurity specifically, because like you said, and like I said earlier, we have a shortage of talent and understanding. And I don't need every engineer to be the cyber expert, but if we get every engineer coming out to kind of understand security a little more, and then a pocket of those engineers becoming the experts, I think that is the way to combat the Chinas and the Russias of the world that are trying to influence our elections or hack into our banking system or our energy system. We are very vulnerable. And one of the getting a little deeper, one of my biggest concerns as an engineer is supply chain.
Yeah.
Understanding your system and protecting it. Everything we talked about can all be taken apart by a fifth tier supplier of a chip that goes into a common product that is all over a critical infrastructure industry or the Navy or the Army or wherever. And that is very, very scary to me. So we need, and I'm dealing with tech companies that deal with cyber supply chain management, and that is the biggest thing. So I'm trying to develop some classes specifically for supply chain, but also a certificate program where an engineer can at least understand more if he's not going to be, he or she is not going to be a cyber expert.
Yeah, and that goes right along with, my degree, going into college. I was an electrical engineer major, but it was different. The college I went to, a small school in Texas called Laterno, and they had an engineering degree with an emphasis in electrical. But the reason that they made it that way is because they made us take mechanical classes, chemical classes, welding classes, because they wanted us to come out with, obviously my emphasis was electrical, but they wanted me to understand all of the other disciplines as well, because if I only designed an electrical system that couldn't be mechanically built, then it was a worthless system. So to the same point, cyber should be part of that same understanding. It doesn't have to be your emphasis. They don't all need to be cyber people, but we do need everybody to have a cyber understanding when they're designing these systems, because they need to have that in the back of their mind to make sure I'm not building an insecure system or a system that can't be secured or makes it extremely difficult to secure, when if I do it in the beginning, it would make it a lot easier long-term to make sure that it's a fixable product.
That's right. Designing stuff below the kernel level, if you will, that helps the cybersecurity engineer design a secure system, because the components are designed. And that's the IoT class that I'm trying to develop. It's trying to help engineers that are going to come out and work for OEMs and develop components that they have an understanding. And that's my biggest push right now, and having fun and working with younger engineers and trying to pass on some of the knowledge that we have as older folks.
That's right. Yeah, it's a lot of fun. I love it. And tell us how to find the information on the charity, the school, the program, all that kind of stuff.
Sure. So like we all love acronyms, my new company is DTCUBED, standing for D and 3 T's, and it simply stands for doing things that are tough, because that is a very horizontal approach to doing anything. And I do some work with my charity on Opportunities Knocking. My web for my company is d-t3.com. That's www.d-t3.com. And the charity is an Opportunities Knocking. It's ANOPPKNOCK.org. And they do a lot of work together at Rowan, but outside of that, they're very, very segmented.
Absolutely. And we'll put all those links in the show notes here. Absolutely hope people reach out. That's an awesome program. And to bring in new engineers, we know that there's a big gap in the skills that we need to be able to take this into the next generation of engineers and designing systems for all these critical infrastructure, whether everything is getting to become more and more critical for manufacturing, supply chain, et cetera. So we need to have this mindset in all levels, not just, hey, Navy ships and, power plants. It's a really bigger problem than that.
Yeah. And to that end, I'd also like to just give some credit to Paragon Systems, my bigger client who gave a nice grant to Rowan University to start this cybersecurity certificate program. And some of my clients, Versec, Obscura, Cohesity, who are all donating tech to the lab at Rowan, so we can start this ICS lab where we can test out and play with different security type tools, and customers can find or students can learn about the best approaches to protecting industrial control systems and operational technology.
That's outstanding. I'm happy to talk to you about how we can get other things in there from a cyber perspective. Obviously, Industrial Defender, happy to help you there, but other things as well. I got a lot of connections. Happy to have that. I think it's super important, and thank you for doing that work.
Great. Thank you very much, Aaron, for having me. And it's a little geeky, but I love talking about this stuff. So if we want to go down any other tangential roads down the pike, I'm definitely in for it.
Absolutely. Thank you for your time today, sir. It was enjoyed the conversation.
Thank you. Bye-bye.
Thanks for listening to the Protect OT Cybersecurity Podcast. If you got some valuable information from today's show, please subscribe, rate, and review the show on Apple Podcasts, Spotify, or wherever you get your podcasts. To learn more about Aaron and to get your free copy of the OT Cybersecurity Solution Buyer's Guide, go to industrialdefender.com. That's industrialdefender.com, or you can click the link in the show notes.